Hello everyone, welcome to Applications Manager free training series. So in today's webinar, I'm going to walk you through how to proactively monitor your AWS cloud applications, and you'll learn how to keep tabs on the performance of your Azure applications. And then we will talk about how we can track critical KPIs across your container orchestration platforms. And finally, we will learn how you can use Applications Manager to pinpoint performance bottlenecks in your cloud environment. So before we go in depth about today's topic, let us take a look at cloud in general. The cloud movement started garnering attention in the early 2010s and has grown exponentially ever since. We have various types of clouds in the industry today. There are two main cloud types based on deployment models and ownership: public cloud and private cloud. Public cloud is owned and operated by a third party cloud provider that makes resources such as servers, storage, and applications available to customers over the internet. In a public cloud, customers share the same hardware, storage, and network devices as other customers, but their data is kept separate and secure. Some examples would be Amazon Web Services, Microsoft Azure, and Google Cloud Platform. In a private cloud, it's owned and operated by a single organization for its exclusive use. It can be physically located on premises or hosted by a third party service provider. It provides greater control over security, performance, and availability when compared to a public cloud. But it requires more resources and expertise to set up and maintain. Some examples can be VMware, OpenStack, and Microsoft Azure Stack. We also have the hybrid cloud deployment model, which combines elements of both public and private clouds. So, in 2021, Gartner had predicted that 90% of the enterprises would move to the cloud. These predictions usually downplay the actual value to avoid overestimating. As of now, 94% have already moved to the cloud. When you look at the market value of the cloud, it is estimated at 599.84 billion for 2023 and is expected to grow up to 832.1 billion by 2025. So why do people adopt a cloud model? One of the main reasons is how easy and quick it is to migrate to a cloud. In traditional data storage methods, the amount of data stored is directly proportional to the physical space it occupies. But that's not the case with cloud storage. You can store any amount of data without worrying about how much you have to scale, not only physically, but also virtually. Another main benefit is that cloud tech is flexible. It allows you to scale new resources quickly, control workloads, and ensure seamless end user experiences. It provides an easier and a more systematic approach to disaster recovery scenario and handles multiple workloads as well. Even though cloud offers a myriad of benefits, it comes with a few challenges, such as mapping dependencies, limited visibility, and lack of control. Cloud apps can be dependent on multiple clouds and on premises technologies, and they may be dependent on hundreds of elements, and discovering these elements are tricky. Some of these elements in the cloud architecture are complex, and the visibility is often minimum. The lower the visibility, the lesser control you have over the output. Sometimes unscheduled downtime and increase in application latency can also occur. Consider this scenario. You want to perform an action which consumes a lot of data. This could make it both time intensive and complex. Now, you want to perform another action which has to wait until the first action is fully executed, since it uses the same resources. This results in a deadlock situation and causes the application to slow down. In a worst case scenario, it may result in server crashes causing downtime. Companies could lose millions along with their reputation if they encounter this situation. Since the visibility into cloud structures is low, it becomes harder to troubleshoot and optimize performance unless a third party is involved. Now, this third party is a monitoring tool that helps you overcome these challenges, and that is exactly what Applications Manager does. Applications Manager is an infrastructure and server monitoring tool which also provides APM on the side. It provides out-of-the-box monitoring for applications and infrastructure components, including application servers, databases, middleware or messaging components, ERP software, web services or transactions, virtual and cloud resources, all of this from a single console. It also automatically discovers applications and maps their dependencies. Take a look at this flow diagram to understand how Applications Manager works. So you can see that you have the cloud infrastructure here, which has the application servers, containers, and all of that. And then we have the native monitoring tools. We have CloudWatch for AWS, and then we have the Azure Monitor for Microsoft Azure, and then we have Google Cloud Operations Suite for GCP, and OCI monitoring for Oracle Cloud. So Applications Manager basically has a metric aggregator. So this aggregator sends an API request to all of these native monitoring tools. So then it aggregates all the data, and that data is then converted into meaningful information. So this can help you make educated decisions. So you can even manage all of your faults, and then you can predict the resource usage and the growth, and you can also analyze the historical performance and trends. All of this data can be viewed on Applications Manager's web console. And if you've downloaded the Applications Manager's mobile app, you'll be able to view it there as well. So Applications Manager monitors all the popular cloud technologies such as Amazon, Azure, Oracle, Microsoft 365, and Google Cloud. So first, let's see how Applications Manager can help you proactively monitor your AWS cloud applications. So Applications Manager basically collects the metrics for Amazon Cloud Services through Amazon CloudWatch. So it makes use of appropriate APIs for different services to collect the data, which is all then compiled and aggregated using the AWS SDK. The performance of a system can be defined in terms of the system's ability to perform a given task successfully. So the performance of the tasks that are executed successfully is measured by the time that's taken to perform the task, the rate at which it's performed, and the resources consumed while performing the task. In general, the efficiency of a given system can be expressed in terms of performance metrics, which you will need to monitor to keep your services running. So we will look at all the important AWS KPIs in a short while. But before that, let's take a look at the AWS services monitored in Applications Manager. So in compute, we have EC2, Lambda, and EBS. So we have the Elastic Compute Cloud and the Elastic Block Store along with Lambda. In containers, we have the Elastic Container Service and the Elastic Kubernetes Service. And in database, we have the Relational Database Service along with DynamoDB. In load balancing, we have the Elastic Load Balancer. So you can also further classify it as application, network, or gateway balancers. So in storage, we have the S3 buckets. And in the notifications, we have SNS, which is the simple notification service. And in queue, we have SQS, simple queue service. And in accounting, we have billing. So let's now switch to the product UI and see how you can add an Amazon monitor and Applications Manager. So this is the Applications Manager's web console. So you click on New Monitor and click on the Add New Monitor. And under Cloud Apps, you can click on Amazon. So you give the display name and you have all the services. By default, all of the services will be chosen. But if you don't want to monitor any of these services, you can just choose to cancel them. And then you'll have to provide the access key ID. And then also provide the secret access key. And then we have the account type. So there are 3 account types, AWS Global, AWS China, and AWS Government Cloud. And we have the regions here. By default, all regions are chosen. If you want to specify, you can specify that as well. So we have child discovery options where you can choose not to discover any child monitors, or you can discover and not monitor them, which is what we call unmanaged, or you can discover and monitor the child monitors. We also have the advanced setting option. So here you have options for action on deleted resources. So if you have a certain AWS resource that you've deleted from the console, AWS console, do you want Applications Manager to continue alerting or stop alerting, or do you want to unmanage the resource or delete the resource? So you can also use regex to filter the EC2 instances, and you can specify the same here. So that's about the advanced settings. So, and then you can specify the polling interval. And if you want to associate this monitor with a specific monitor group, you can do so here. Otherwise, you can just add the monitor. So now let's see how the monitor looks. So this is the Amazon monitor. So as you can see here, we have the overview tab where you have the overview of all the resources, your compute resources, storage resources, database resources, containers, and all of that. And we have separate tabs for each of the services. So except for S3, SNS, SQS, and billing, you have specific resources under each one. And when you click on each of those resources, we have more details. So in compute, let's talk about EC2 instances. So this is your EC2 instance, and here's your overview tab. You can check out the CPU utilization, network traffic, the disk IO details, read ops and write ops, and you have the OS level metrics where we specify the available memory, committed bytes in use, disk utilization, and disk space details. And you have the attached volumes. So you have volume details, when it was created and when it was attached, and whether it will be deleted on termination. And we have graphs about volume versus idle time, volume versus read latencies. And we also have volume versus bandwidth details here. And you can also see that there are details about volume traffic and volume IO. So all of the data is specified both in tabular and graphical formats. And we also have the configuration tab that gives you the configuration details of your EC2 instance. Similarly, we have Lambda. So we have the overview tab where we have, basically a general glance about your Lambda resources. Here in Lambda, the critical KPIs would be to, track the invocation rates, delivery failures, duration, and execution. These basically describe the rate at which invocations are executed and the rate at which success is achieved. So here you can see the failed invocations, throttled invocations. You can even see the error rate. So you also have the executions, you're tracking them along with your duration graphs. So you can also track the iterator age and delivery failures here. And then we have the configuration tab. So this is the AWS Lambda. So moving on, similarly, we have Elastic Beanstalk environments as well. So moving on to containers. So we have both ECS and EKS. So this is your ECS monitor. So you have the overview tab. So you have the usual cluster information. And at a single glance, you'll be able to see which tasks are pending, your EC2 tasks that are running. You also have the Fargate tasks. So you need to know that ECS is basically tightly integrated with EC2 and Fargate instances. So the resources can be monitored under the cluster performance tab. So here you have the CPU reservation and CPU utilization percentage. You have the memory details. So you have graphs of CPU usage and memory usage. We also track the disk IO throughput along with the cluster network input outputs. So we have the tasks tab where we track all the tasks. So we have the ID, the status of the task, the connectivity, the launch type, and the configured memory for each of these tasks. So we also have task info where we talk about the definition, when it was created, when it was started, and started by, and all of those details here. So we also have the services tab in which you have the service status, service insights, and service details along with service events. So you will be able to see the CPU utilization, memory utilization, and all of these critical KPIs for services. So for events, you'll also know when the event was generated and what message was received. And then we have the container instances tab, where we have instance related CPU and memory usage. So you can see the instance CPU used, instance memory used, along with file system utilization, and you have the network usage as well. And we have the container instances, instance insights, along with resource details. So you have all kinds of data in both graphical and tabular formats. So that's about the Elastic Container Service. Similarly, you will have it for the Elastic Kubernetes Service. Moving on to databases, we have RDS. So an RDS, so like any other database, the KPIs are basically metrics that are related to the resources. RDS is basically something that allows you to provision and operate RDBMS in cloud and can be deployed widely, used in all database engines such as MySQL, MS SQL, PostgreSQL, Oracle, and MariaDB. So here in the overview tab, you have the CPU utilization of your database server and your available storage, along with your available memory, the swap usage, and your database connections, number of database connections. And then we have the disk IO tab, where you can track the IO throughput and IO latency along with your IO operations. And then we have the network tab, where we track the network traffic to the RDS instance. So we have the incoming traffic as well as the outgoing traffic. And finally, we have the configuration tab, which has the configuration details of your RDS instances. Similarly, you have for DynamoDB as well. So moving on to ELB. So we have two types, application load balancers and network load balancers. So this is your application load balancer. Here we have the overview tab, which basically shows you the average latency of your application load balancer, the total number of requests, the requests that come in every minute. And then you have the connection details. Here you can see the number of rejected connections. And you can also track process bytes, rule evaluations, and consumed LB capacity units. And then we have the errors tab, where you can track all the connection errors of your application load balancer. And then we have load balancer errors as well. That is both server and client errors. And then we have target groups. So here, basically in any load balancer, it's important for you to, track your healthy and unhealthy hosts in your target hosts. So here you can see the healthy and unhealthy hosts, and you can see target group requests, and you also have performance metrics here. So you can also track the average target latency along with total requests and requests that each target receives. You also have the error details, target connection error details. Then we have the targets tab, which gives you details about the targets. You have the target ID, the group that it belongs to, the port, and the status of the target, and the reason, and all of that. And then you have the configuration tab, which gives you all the configuration information of your application load balancer. So then we come on to the S3 buckets. So this is pretty simple. So in S3 buckets, you basically have details about all your storage resources. So, I mean, the number of virtual folders, the number of objects, and you can also track the request statistics for your buckets, the number of requests you receive every minute, the get requests, put requests. You also have the first byte latency along with the total request latency in your S3 buckets resources. So moving on to SNS service. So here, SNS is a notification service. So the main KPI would be to track the notification delivery and your failure rate. So here you can see the total number of notifications delivered. And here you can see the total number of notifications that have failed. So you also have it in the percentage. And you can track your message throughput, your delivery rate, along with your failure rate. And you also have region-wise metrics for your SNS. So you can track the topic count, the messages published, the notifications that have been delivered, that have failed, and SMS month-to-date charges as well. So this is about the SNS service. In SQS, as you can see, you will have to track the queues, the type of queues, the region code along with the arrival rate, the messages that is received per minute, and you also have the completion rate and the created time. So in billing, you can monitor the expenses that are incurred for all of your AWS services that you have deployed. So you can basically set thresholds and avoid overspending. Here you can see the total expenditure and forecast graph, and you can see the services and tax graph where you can see the month to date services cost along with the month to date tax. And here you can see the month to date top services by send, and you can also see that in the tabular column. So here, by taking a look at this in a single glance, you will be able to see where you can reduce your spending or where you've been spending a lot. So billing can monitoring all of this can help you cut down your costs. So that's about all of the AWS services that are monitored in Applications Manager. So let's go back to our presentation. Moving on, we're going to the next topic of the day, which is how we can keep tab on the performance of your Azure applications. So here are the Azure services that are monitored by Applications Manager. So you can see that there are Azure virtual machines, Azure service bus, and you have SQL databases, storage accounts, along with your Kubernetes service. So Applications Manager collects all the data with the help of the Azure SDK. Just like how in Amazon we had the AWS SDK, here we have the Azure SDK, and all of this is collected in the form of metrics and events. And basically Applications Manager provides you with a unified view in Applications Manager. So now let's switch to the UI to understand how we can add an Azure monitor in Applications Manager. So you go to the new monitor tab and click on add new monitor. And under cloud apps, you click on Microsoft Azure. So you specify the display name, and then you will have to specify the subscription ID of your Azure account. And then you specify the Azure services that you want to monitor. So by default, all of the services will be chosen. If you don't want to monitor certain services, you can just choose to omit them. And then you choose the account type. You have the Azure Global and Azure Government Cloud types. And then we have the discovery mode. So there are three types of discovery modes in Azure Monitor. First is the AD application and service principal. If you choose this, you will need to provide the client ID, the tenant ID, and the application key. Or you can choose OAuth. So in OAuth, Applications Manager basically enables you to configure an OAuth provider which generates an access token that can be used to authenticate or enable access without sharing any credentials directly. So if you want to add a new OAuth provider, you can add the same here and make use of the same. Or we have the third method, which is the Azure organizational account for PowerShell. So this is a method that I will be using to add the monitor. So you just have to specify the username and the password. You can specify the timeout along with the polling interval. So if you want to associate this monitor with a monitor group, you can do so here. Otherwise, you can just add the monitor. So now let's see how the monitor looks. So this is the Azure monitor. Just like AWS, we'll have an overview tab and a tab for each of the services in Azure. So first in the overview tab, you have the details about the resources, the number of resources, number of virtual machines, number of SQL database instances and SQL managed instances and your load balance account and all of that. So then we have the virtual machines. So the overview tab, you have the CPU utilization of your virtual machines. You have the number of CPU credits. And then in the CPU tab, you have more details of CPU metrics. You have the wait time, idle time, and processor time. And then the memory tab, you will be able to see the memory details, the available memory, the used memory, use swap memory. And then we have the disk tab, where you have details about read throughput, write throughput, disk IO ops, disk IO latencies, and you even have the disk spacing details. And in network tab, you will have the network traffic for your Azure virtual machine, the incoming and the outgoing traffic. And you also have the configuration tab, which basically lists the configuration details of your Azure virtual machine. Moving on to storage accounts, there are two types of storage accounts. So we have the Azure standard storage account and the premium storage account. So let's take a look at the standard storage account. So here you have the overview where we talk about the blob availability, table availability, queue availability, and file availability. So at a single glance, you'll be able to see how your storage account is performing. And you also have the basic configuration information here. And then we have a tab for blobs where you can track the capacity, throughput, latency, and all types of errors for your blobs. So timeout errors, client errors, server errors, authorization errors. You'll also be able to track your successful requests for your blobs. Similarly, you have the same for tables. We have the same metrics except it's for tables. So we have the table count, we have throughput of the tables, latency, and all types of errors along with the successful requests. Similarly, we also have files where we have the capacity of the files, the file count, file share count, and we have the throughput of the files, and we have the request failed, throttling errors, different types of errors for your files, along with your successful requests in your files. Same way, we have details about queues in your Azure storage account, where we talk about the capacity, throughput, uh, requests, failed, timeout errors, all types of errors, along with the successful requests. So that's about the Azure storage account. Moving on, we have Azure SQL databases. So here we have the overview tab where we have details of resource utilization of the database, the CPU utilization, DTU utilization, IO utilization, along with the database size. You can also track the connections and basic performance statistics of your database. And we have different tabs that represent top queries by CPU, by IO, and all of this will specify the average value along with the average execution time. It will also specify the query and when it was last executed in your Azure SQL database. So you have the top slow running queries where you can see what's the maximum execution time and what's the minimum execution time. We also have the frequently executed queries. So you have the query and the average execution time and execution count as well. So when you see all of this, you can see where you can perform tuning and try to enhance the performance of your database. This is how Applications Manager can help you enhance the performance as well. So you also have details about most block queries, and the configuration tab has details about the configurations of your Azure SQL database. Moving on, we go to the Azure Service Bus. So here we have, in the overview tab, we have details about the namespaces of the bus, the request statistics, the request errors, message statistics, and message details, along with your connection statistics, the connections opened and the connections closed in your service bus. We also have details about the queues in your bus, so the status of the queues, the total size, the free size percentage, and the number of active messages in that specific queue. So we also have graphs for active queues based on incoming requests and active queues based on messages. And we also have queue metrics listed in the tabular format. And then we have topic details where we have details of the topic, the status of the topic, the number of active messages in the topic, and Just like queues, we also have graphs for active topics based on incoming requests, active topics based on messages, and we also have uh, topic metric details. And we have the configuration tab, which talks about the configuration of your Azure Service Bus. So Kubernetes service, I think we will cover in the next part of the session. So let's move on to SQL managed instances. This is actually a pretty new feature in Applications Manager, where we're now tracking Azure SQL managed instances. So the overview tab basically has details about the instance state and the provisioning state, and also helps you identify the CPU usage, storage, all at a single glance. So you even have details of IO requests of your managed instance and the average IO statistics along with your total IO statistics. Then we have the databases tab, where we have information about the databases in your SQL managed instances. So we have the status of the database, the location, when it was created, and the earliest restore date as well. So, and then we have the configuration tab, which basically lists the configuration details of your Azure SQL managed instance. In load balancer, just like Amazon, we have the Azure load balancer. So here we have the overview of your load balancer, and we have details about the front end and back end statistics. And we also have details about the configuration. So that is basically about the Azure load balancers. So now that we've seen these are the Azure services that can be monitored in Applications Manager, and how in each of these services you can track critical KPIs, and you can basically even set thresholds and set up alerts if you want to, identify performance problems, which we will again see in the last topic of the day. So let's move on to the presentation. So next, we will be talking about how we can track critical KPIs across your container orchestration platforms. So containerized orchestration platforms are basically tools that are designed to help manage and deploy applications that are containerized. These platforms provide a way to automate the deployment, scaling, and management of containerized applications, which make it easier for developers to work with complex distributed systems. So, containerization itself is the process of packaging an application and its dependencies into a container image, which can be run on any compatible system. So, containerized applications are typically smaller and are more modular than traditional monolithic applications, which makes it easier to manage and deploy. So, why is container monitoring important? So, in Applications Manager, you can monitor Docker, Kubernetes, and OpenShift platforms. So, let's now talk about why container monitoring is important. So, firstly, it helps ensure that all mission critical containerized applications are available and are performing as expected. So, by monitoring metrics such as CPU and memory usage, response time, and throughput, you can quickly identify issues and take action before they impact the users. So, containers can also be scaled up or down based on demand. But without monitoring, it can be difficult to know when to add or remove containers. So, by monitoring container usage, you can optimize resource allocation and scale more effectively. So, then containers are basically highly dynamic and can change rapidly, which make it very difficult to identify issues without monitoring. So, with a monitoring solution in place, you can quickly identify issues such as container crashes, network connectivity problems, or application errors. Containers can also pose security risks if not properly monitored. So, by monitoring container images and network traffic, you can identify vulnerabilities and take action to secure the environment. Containers can be a cost effective way to deploy application, but without monitoring, it can be difficult to optimize the costs. So, by monitoring resource utilization and identifying areas of inefficiency, you can save money on infrastructure costs. That's why it's important to monitor containers. Moving on to Kubernetes monitoring. So Kubernetes monitoring is the process of monitoring the health and performance of Kubernetes clusters, nodes, and applications that are running on them. So here are some of the key performance indicators that you'll need to consider. Firstly, you'll need to monitor cluster resource utilization, which means you'll need to monitor the CPU, memory, and storage resources across your Kubernetes cluster. So this helps you identify overutilized or underutilized nodes and allows for efficient resource allocation. You'll have to monitor the pod status. Monitoring the status of pods running in the Kubernetes can help you understand which pods are running and are healthy and enables quick identification of failed pods. Similarly, node status. So you need to monitor the status of nodes in your Kubernetes cluster. So here also you can identify if you have any failed nodes. Network traffic. So monitoring the network traffic between the pods and services in your Kubernetes cluster helps you identify if there's any issue with your network connectivity and helps you optimize your network performance. You can also monitor the deployments, services, and PV and PVCs in your Kubernetes cluster. So let's now shift to the Applications Manager UI to see how we can add a Kubernetes monitor. So you go to the new monitor link and click on add new monitor. And under virtualization, you click on Kubernetes. So you specify the display name, and then you will have to give the host name or IP address. So this is basically the host name of the server where Kubernetes is running. And you'll specify the credential details. You can either use the below credential, or if you already have a credential list, you can choose from the credential list. So then we have the public key authentication. So you can check this box basically to enable public key authentication. This is basically the SSH key for SSH authentication. So here you specify the username and password. And then you specify the prompt, which is usually $, but then you can also have the hash symbol or anything else as well. So then you have the SSH port. So the default SSH port is usually 22. And then you have the monitor specific namespaces option. So you can enable this if you wish to monitor only specific namespaces in your Kubernetes environment. So you can include those namespaces, or you can choose to exclude certain namespaces in your Kubernetes environment. And then you can specify the timeout and also the polling interval. And if you want to associate this monitor with a monitor group, you can choose to do that here, or you can just add the monitor. So now let's see how the Kubernetes monitor looks. So this is the Kubernetes monitor. You have the overview tab where you have details about all the namespaces, and you have details about the pods. So when you want to have an overview, you can check the maximum pod count, and you can also see the top 5 nodes used by pod count. Cluster usage details, like I was telling you in the KPIs, you will need to monitor the cluster resource details. So you have the average CPU and cluster memory usage, along with details about your nodes, clusters, and you also have the component details here. And then we have the node tab. So you have details about top 5 nodes by memory, top 5 nodes by CPU, and you have node memory and CPU details present here. You also have node pod details. You have the pod usage details here, and you also have the node details. And then we have the pods tab, where we have details about the pods, the namespace, the node name it belongs to, the application, the type of pod, uh, pod status. We also have the top 10 pods by memory details, top 10 pods by CPU details, and we have all of this specified in the tabular format as well. And you have the container details. So you can also, monitor the services. Like I said, it's one of the KPIs. All the services in your Kubernetes, the namespace, application, service type, along with the protocol. You can also monitor your deployments. So you can see the replica count along with the namespace. And you can also monitor your persistent volumes in your Kubernetes environments. So that is about the Kubernetes monitor. Let's now move on to the last topic of the day, which is basically how you can pinpoint performance bottlenecks in your cloud environment. So Applications Manager also helps you identify bottlenecks inside and outside your cloud environment. So how can you prevent service outages? In Applications Manager, you can prevent service outages by creating and associating threshold profiles to key performance indicators. So you can also trigger automatic actions to be performed on threshold breaches. So with the help of anomaly profiles, you can also detect the performance degradation in applications. So the alarms are basically generated when thresholds are breached. These can be escalated via email and SMS. So when a service is down, Applications Manager automatically identifies the source of the issue with what is called the root cause analyzer and takes corrective actions such as a cloud action that can be triggered automatically when you associate them with a specific threshold profile. So let's see how we can create a threshold profile in Applications Manager. So you click on the threshold profile and click. So here you basically have three types: the standard profile, adaptive profile, and anomaly profile. So you can create the profile for either numeric values, string values, or float values. So you can just specify and for each you can basically configure three different severities: for critical severity, warning severity, or clear severity. So if the monitored value is like greater than 80, then you raise a critical alert. So you can specify the message that you want to raise here. And similarly, for warning severity, you can specify a certain limit, and for clear as well. You can also apply these thresholds based on business hours. Then you have the adaptive profile. So here we have two types: the baseline values and the custom expression. So for baseline values, you can basically set a fixed dateline range from the drop down here. So you can pick a specific week to choose as the baseline, or you have what is called the custom expression, where you can use specified system variables to configure your thresholds. Then we have the anomaly profile. See, the anomaly profile is basically when Applications Manager lets you know that the value of a certain KPI is more or less than the usual values. So you have the anomaly detection based on baseline values or on custom expression. So if you choose the baseline values, you can choose a fixed baseline based on week 1 of February 2023. So you also specify when you have to detect the anomaly, which means if you want to detect anomalies in your CPU utilization and you've chosen week 1 of Feb 2023, if the CPU utilization of a specific Kubernetes cluster crosses 20% more than the value that's specified in week 1 of February 2023, then Applications Manager will send you an alert and say, hey, there's an anomaly and the value of CPU utilization is 20% higher than what it usually is. So the baseline can be set in this drop down, or you can choose to specify a custom expression where you will be using the system variables. So this is how you create a threshold profile. Then we have what is called actions. So you have what is called a cloud action. So here you can specify. So here, what is this? It's a remedial action that can be performed when an alarm will be generated. So in cloud actions, you can choose to either start the instances, stop the instances, or restart the instances. So you can choose the target instance or the virtual machine. So this action, when it's executed, should it start all the EC2 instances in the monitor group or the specific EC2 instance? So you can, and if you want to be notified after the action is executed, and you can just create the action. So, and then now we'll see how to configure alarms. So when you configure alarms, you can do it for a specific monitor, wherein you'll have to specify the monitor type or the monitor, or you can choose to do so for a monitor group, wherein the alarm will be configured for all the monitors in the group, or you can choose to do so on the monitor type. So for this specific type of monitor, this alarm will be configured. So then you can choose to associate thresholds for these attributes. So for example, CPU utilization. So here you can choose to configure actions at the attribute level. Like I said, if the CPU utilization is greater than whatever is specified in your threshold profile, you can choose to, execute an action. Like I just showed you, if you want to execute a cloud action for for critical severity, you can just specify it here, and for warning or for clear severity. So this is how Applications Manager basically helps you pinpoint performance bottlenecks in your cloud environment. So basically, it helps you create thresholds, which when breached will trigger an alarm. And so you will receive an alert either through SMS or email and whatever you configured it. And if you want remedial actions, you can associate actions with your threshold profiles, wherein your VM will be either started or restarted without any manual interventions. So you can also analyze application lags in Applications Manager. For this, we use what is called the APM Insight Agent. So this basically is an add-on in Applications Manager, and this part is covered in the part 2 of this training series. So if you want to know more, you can check out our website or the YouTube channel. So Applications Manager also helps you prevent server downtime. So like I told you, it monitors various types of servers, databases, services, and apps, VMs, and other infrastructure monitors. So you can basically map the dependencies between all the cloud and non-cloud elements to gain deeper visibility. So when you monitor these in synergy with your cloud services, you will be able to achieve an all-around high performance across your IT infrastructure. So this can preempt any issues that may result in unresponsive services. By also using advanced analytics, you can anticipate the resource usage, wherein you will be able to predict the resource usage and growth with our forecast and capacity planning reports and make educated decisions. So here's a quick recap of what we learned in today's session. First, we understood how we can proactively monitor your AWS cloud applications, and we learned how we can keep tabs on the performance of your Azure applications. And then we learned about how we can track critical KPIs across your container orchestration platforms and how we can pinpoint performance bottlenecks in your cloud environment. Thank you for